Hi guys, welcome to Math. Today I'll be going through 3 quick tips with you on solving logarithm equations for O levels. The first 2 tips focuses on the change of base. One common question I often get from my students is, what base should we change to? In most cases, regardless of what base you change to, you can still solve the questions. But here are 2 tips on base changing that will make things easier to solve. When the bases are all numbers, the first tip is to change the bases to the value of the smallest base. This will help you simplify the equation much faster. Let's take a look at one example. Suppose we have this equation over here with two different bases, 4 and 16. I will demonstrate on the left how changing the base to the bigger number, 16 for this case, might complicate things. If we were to change the base to 16, we will encounter this, which is difficult to simplify. On the other hand, if we were to change the base to the smaller number, 4 in this case, we will get log base 4 16, which is definitely much easier to simplify. 16 can be changed to 4 square, and log base 4 square is simply just 2. When you encounter different bases involving x and numbers, the second tip is to change the bases to the smallest numerical base instead of 2x. It's simpler to solve. Let's delve into an example. As you can see in this equation, we have two logarithm terms of different bases. One with base of x and the other with base of 5. Let's start with the change of base to 5. We change the logarithm of base x to 5 and we arrived with a fraction where its denominator is log base 5x. To make things easier to visualize, we sub u to be log base 5x. After simplifying, we will get a quadratic equation and we solve it to get u equals half or 3 over 2. But don't forget, what we are solving is x, so we need to sub back the log base 5x. Next, we convert the logarithm form to the exponential form, and we will get x equals 5 power of half or 5 power of 3 over 2. These two solutions are easy to solve as we can simply press our calculator to find the value or leave it in the third form, depending on what the question requires. Next, let us take a look at what will happen if we change the base to x instead. So we proceed to change the logarithm of base 5 to base x, and we arrived with a fraction where its denominator is log base x, 5. Similarly, we sub u to be log base x, 5. Similar to the right side, we will get a quadratic equation and we solve it to get u equals 2/3 or 2. We sub back the log base x, 5, and convert the logarithm form to the exponential form. Here comes the more complicated part. Here, we get x power of 2/3 equals 5. To solve for x, we need to cube the whole equation followed by square root. For the other answer, we can just square root the x squared to get x. Comparing to the first method on the right, this is more difficult to solve, while changing the base to a number instead of x leads to an easier way to obtain the answer. For this last tip I want to share with you, I will have to first illustrate with an example. We have this equation over here. With tip 1 in mind, we change the base of log to 3. We will eventually arrive with 2 at the denominator because log base 3 square is equals to 2. Our first instinct is to multiply 2 throughout to get rid of this denominator. Subsequently, we simplify the two logarithms into one using the law of logarithm and convert the logarithm form to the exponential form. Next, when we expand the denominator, we end up getting an x with a power of 4, and we are unable to solve it. To remedy this, we backtrack to how this x power of 4 came about step by step. So, this x power of 4 arises due to this square, which comes from these two. This 2 is the result of us multiplying the 2 throughout earlier. To fix this, we simply have to find another way to get rid of the 2 at the denominator. The 2 at the bottom can be rewritten as half log base 3 4x squared. If we were to shift this half as the power of 4x squared, this is equivalent to 2x, and we have successfully get rid of the 2. We will continue to proceed. And the problem of encountering x power of 4 is avoided. We have reached the end of this lesson. To give a quick summary, today we learned that whenever we are solving logarithm equations, changing all numerical bases to the value of the smallest base will help simplify the equation for easier solving. Secondly, we learned that when there are both numbers and x as bases, opting to change the bases to the smallest numerical base will lead to a simpler equation to solve as well. And in the last tip, we also learned how to backtrack and avoid a step that will lead to a higher power of x that is difficult to solve. Let me know if you have any questions by leaving a comment below. Check out our other math videos for more neat tricks that will help you overcome challenges in solving math problems. Thank you for watching and subscribe for more math tips.